Imagine buying a new car today, and even after 4 5 years, it keeps getting noticeably better, smoother performance, new safety features, better range or efficiency, all without you spending extra money or visiting a workshop. This isn't imagination. This is exactly what software defined vehicles SDV are bringing to life. The car industry is going through its biggest change in decades, moving from pure hardware machines to software driven smart vehicles. Just like how basic phone became powerful smartphone. In this video, I'll explain everything in very simple terms, starting from how car used to be built, what HDV really means, the huge market numbers, and real examples of how this will change your daily driving experience. Even if you have zero background in cars or technologies, you will fully understand it by the end of the video. Let's get into it. Let's first understand how the internal design of car is completely changing. In traditional cars, manufacturers used something called distributed architecture. That means the car had hundreds of small separate computers known as electronic control unit (ECU). Each ECU did only one job. One handled brake, another for light, another for audio system, all connected by a huge network of wire. It worked, but it was messy, heavy, and extremely difficult to update when features were needed. Now the industry is shifting to much cleaner and powerful approach. This is old distributed architecture. You can see many small ECUs scattered all over the car with complicated wiring. Now current zonal SDV paradigm, the car is divided into few major zones, each controlled by stronger computers. Upcoming future zonal architecture with V2X, the car can directly talk to other cars, traffic lights, and the cloud in real time. This shift is making cars simpler on the inside but far more capable outside. Here comes the new heart of car, the high performance computer HPC. Think of it as replacing many small brains with one super intelligent central brain. You see dedicated CPU clusters for different tasks, memory systems, graphics unit for cameras and displays, and connections like Ethernet, CAN, FlexRay, USB, PCIe. It even runs two operating systems, one super fast for safety and one for entertainment and apps. This powerful central computer is what makes continuous software improvements possible. In simple words, in an HDV, software becomes the main driver of the car's capability instead of fixed hardware. You can add new features, improve performance, and fix issues through over-the-air updates, meaning the manufacturer sends improvement wirelessly just like your phone update. This is a big deal because your car can keep getting better features for many years after you buy it. In one of the roundtable conference, Dr. Anchal Jain, CEO of PMI Electromobility, said this.
So firstly, we always like to call our EVs as a computer on wheels. So when you are putting the context of having a software SDV or a software developed vehicle, so that is where exactly EVs are.
Let's look at how massive this shift actually is and what it means for normal people like us. The numbers are seriously impressive. This report breaks down the HDV market by regions and applications. Asia Pacific is already leading, and you can see strong growth in safety systems, autonomous features, and infotainment. Now, analyzing the growth chart, in 2025, the global HDV market was already worth 271.77 billion. And by 2033, it is projected to reach an incredible 2,445 billion, growing at 31.6 CAGR every year. To put it simple, this is one of the fastest growing industries right now. That means huge investment, new jobs, and rapid innovation in coming years. This diagram shows how everything connects. The car, cloud service, digital twin, and smart systems working together like one intelligent platform. Now here's how you will actually experience this in real life. Many people already using advanced electric cars notice that every few months their car feels a bit better. For example, one day you wake up and suddenly the battery gives you noticeably more range on the same charge. Or the car becomes smoother in traffic because of a background update. It feels natural, like your phone getting a useful new feature. No drama, no service center trip. Arun Kapoor, CEO of JBM, explained the technology behind this.
That we have got a lot of data coming and tons and petabytes of data is coming. In my particular case, we are generating almost 5 terabytes of data every day. And we are analyzing them. We have created digital twins. Now what does it do? So when you get such a data, you start designing the vehicle based on the real conditions. So it's not only software, but we get a lot of insights about the mechanical systems, range, everything. And at that point, you can decide, hey guys, for this terrain and this market and this geography, you can reduce the weight, you can do some restructuring, you can do some changes in the air conditioning system. Now that comes from the insights of the battery.
He is exactly right. Software is vital for battery health. By using digital twin, real-time virtual models of the vehicles, manufacturers can gather massive amounts of data to optimize performance, range, and manufacturing efficiency based on real-world usage. Raj Kiran, Senior Director from PTC India, also highlighted a big challenge for traditional companies.
One of the big challenges is our large companies are thinking hardware first. They've been thinking hardware first and then force-fitting software into the development cycle, which is not exactly in line with how software-defined vehicles need to be looked at. I think it's a fundamental redefinition of the way engineering should be done, which is looking at software platforms first and then connecting the distributed ECUs and redefining the ECUs as well within a vehicle.
To wrap it up, software-defined vehicles are transforming cars from fixed mechanical products into living, improving intelligent platforms. This change brings better safety, more personalization, longer vehicle life, and completely new experience for drivers. The cars of tomorrow won't be just for transportation. They'll be smart companions that keep evolving with you. And it's not just for electric cars. Arun Malhotra pointed out.
So the potential is huge. And I would say that when we say these SDVs is only for electric, I think we are not doing justice to it, because the potential of SDV is much beyond. Whether we like it or not today, the penetration of EVs is still limited.
Yeah.
And I would say the adoption will become better if these technologies, SDV, is used for other vehicles, whether it's hybrid or the conventional vehicles. So this is something which is unique. But I think the benefit is really in commercial application. Look at SDVs in terms of mining, remote areas. There's something phenomenal potential. So I think we are still sitting on the tip of the proverbial iceberg. Potential is huge, but I think it has to become mainstream. It can't remain only electric. It has to be the hybrid, it has to be the CNG, because even normal vehicles are having a lot of software. So I know it's a more challenging task, because there you have to start with software and hardware combining. But that's the journey we need to take to make it successful.